Okay, so today we're going to be talking about roots, square roots and cube roots. So when you're going to take the root of a number, you're going to see this sign. Looks kind of like a check mark, a little bit like a division symbol. It's not. It's called a radical. And if there's nothing there, right, in front of that radical, then there's actually, it's kind of like when we have an invisible, like 1 in front of an x, there's an invisible 2, right? So if there is no number there, the number is a 2. It means you're going to be taking the square root. So what is a square root? So first of all, let's think about a square, right? Let's think about a square that is 3 units by 3 units. Okay, so when you have a square and it is 3 by 3, then, right, we can look and see that there are a number of squares within that square. And so the area is the number of squares. And if we count them up, we're going to see that in a 3 by 3 square, there are 9 smaller squares. Okay, so 3 times 3 is 9. That's why when you take the area, you multiply the 2 sides of a square. Okay, so that means that if we were to take the square root of 9, right, so there are 9 squares, the square root, so how long is each side of that square? That makes the 9 little squares. Then the square root of 9 is 3. And we show that with the 9 under the radical. And we can think of 9 is 3 times 3. So, which is 3 squared, right? So that's what the exponent 3 squared. That cancels out the radical, so the answer is 3. All right, so what about a cube root? Well, we need to think about a cube, right? And how many cubes are in a cube? So you can see this cube is 3 by 3, but if you kind of break it apart, it's full of a bunch of little tiny cubes, a lot of tiny cubes. So how many of these tiny cubes, right? So we can look at a corner one, it's kind of easy to see how many of these little tiny cubes are in this bigger cube that is 3 units by 3 units by 3 units. And if we could count them all up, we would see that there's 27, right? So 3 times 3 times 3 is 27, right? So that's the volume, that's why we multiply the height, the width, and the length. There's 27 little cubes in there, so the cube root of 27 is 3. Right? And we would write that with a radical over 27, but we wouldn't just leave it blank. We need to make sure that in this spot it's not blank, that there is a 3 there. That means the cube root. So what number multiplied 3 times in a row gives you 27? Well, that number is 3, right? So the cube root of 3, right, and that cancels out that 3 exponent, is 3. Now, some roots are perfect and some are non-perfect. So what is a perfect root? A perfect root has an answer that is equal to an integer. So the square root of 4, right? 4 is 2 times 2. So the square root of 4 is 2. The square root of 25, right? Our doubles, we should know our doubles multiplication. 5 times 5. So the square root of 25 is 5, equal to an integer, right? Square root of 100, 10 times 10 is 10. Square root of 400, right? 20 times 20 is 400. Square root of 49 is 7. Those are perfect roots. So non-perfect roots are roots that don't come out to an integer, right? They don't even come out to a terminating decimal. They don't come out to a repeating decimal, right? So they come out to decimals that never repeat and never terminate. They're like pi. So anything that is not a doubles in multiplication. So 7, not perfect square root. 20, not perfect. 5, not perfect. So what are our perfect square roots? So you should know these. We should work on learning these by heart, right? 1 times 1 is 1, square root of 1 is 1. 2 times 2 is 4, square root of 4 is 2, right? So our perfect square roots, square root of 9 is perfect. 4 times 4, square root of 16 is perfect, right? So you can think of your doubles, and those are all perfect squares, okay? So square root of 64 would be 8. The square root of 81 would be 9. The square root of 100 would be 10. Square root of 121 would be 11, right? And then 12 times 12 is 144, so the square root of 144 is 12. 13 is 169, and I know mine up through about 15, but I'm out of room, so, right? Now, cube roots, so perfect cube roots, you know, they start getting, cube roots get large really fast, but so 1 times 1 times 1 is 1. The cube root of 1 is 1. 2 times 2 times 2 is 8. So the cube root of 8 is 2. 3 times 3 times 3 is 27. So the cube root of 27 is 3. Okay, so then we're going to look at, all right, so 4 times 4 times 4 is 64. Cube root is 4. 5 times 5 times 5 is 125. The cube root is 5.